Continuing our discussion on polynomials, in this lesson we are going to talk about how do you find the zeros or the solutions of a polynomial and what is the linkage between the coefficients and zeros of a polynomial. Okay, so to begin with, we will go ahead with the examples of a quadratic polynomial. So a quadratic in general form is written as ax squared plus bx plus c, where a and b are called the coefficients and c is a constant, right? Or if you were given two zeros of a polynomial, then you could write an equivalent form of this quadratic to be x minus alpha times x minus beta, right? These two forms are equivalent. Let's put a number on them. So this is 1, this is 2, and there is one more equivalent form that would be written as x squared minus alpha plus beta x plus alpha times beta, where alpha and beta are the two zeros of this polynomial, right? All of these three expressions, they are equivalent to each other. The only difference is in the expression number 1, we are making use of these coefficients and constant. But in the expression number 2 and 3, we are making use of the zeros of a polynomial. All right. So this is about quadratic. And you must notice that based on these three forms, we could also obtain a relation between the zeros and coefficients. And that relation is something like this, that the sum of the zeros, alpha plus beta, is equal to negative of coefficient of x divided by the coefficient of x squared. And the product of zeros is equal to alpha times beta, which is the constant term divided by the coefficient of x squared. Well, if you compare the form number 1 versus 3, you will understand this relation very quickly. All you have to do is divide the entire expression of 1 with this value a, okay, and then you will get this relation. Okay, now let's take a look at some examples on how do you use one of these forms to find the zeros, or if you are given zeros, then how do you build a polynomial. Okay, so let's take a look at our very first example. Now, in this example, we have been given that find a quadratic polynomial in x if the two solutions, the zeros of that polynomial, are 6 and 2. Meaning, we could use either the form number 2 or the form number 3 to build the polynomial that we want, because we already have these two zeros, right? I would pick the polynomial number 3 because it's just very easy to handle. So it is x squared minus alpha plus beta times x plus alpha times beta, right? So as I simply substitute these values 6 and 2 in place of alpha and beta respectively, I get that x squared minus 6 plus 2 times x plus 6 times 2, and this is equal to x squared minus 8x plus 12, right? Very simple, right? So let's take a look at another example. We have this quadratic equation 5x squared plus 6x plus 1. We need to find two possible roots of this polynomial, all right? So when I take a look at this expression, I see that this is very much equivalent to ax squared plus bx plus c, and I need to convert it into the form number 2 so that I can find alpha and beta, right? So the solution technique is very simple. What we do is we take a look at this middle part, the one that has a coefficient of x, and we try to break this down into two parts such that the sum of those two parts is equal to 6. So let's say one of that combination is 4 and 2. 4 plus 2 is equal to 6, right? But the product of these two has to be equal to the product of the coefficient of x squared and the constant term, which is 5 times 1, right? But 4 times 2 is not equal to 5 times 1. So this won't work. That means I need to look for another combination, and one of those combination could be 5 and 1, right? Because 5 plus 1 is equal to 6 and 5 times 1 is equal to 5, which is exactly the product we have as we obtain the product of these two numbers, right? So that means I could easily write this expression into something like this, that 5x squared will be written as it is plus 5x plus x plus 1. So now you make two subgroups out of it. One of those could be something like this, that I collect these two terms 5x squared and 5x and take something common out of it. So applying the distributive principle, I see that 5x could be factored out. What remains inside the parenthesis is simply x plus 1. And this is x plus 1 as it is. So we will write here and then we'll simply write 1 outside the parenthesis. Now you have one more factor, which is x plus 1, that could be taken out of these two subgroups. And as you do so, you have x plus 1 here, it will come out, and what remains inside. Another set of parentheses would be 5x from here and 1 from here. So now you have converted your expression, what was right here, into an equivalent form, which is right here. So the next step is simply equate this whole thing equal to 0, because this is what you need to find, that whenever you substitute any value of x, this whole expression has to turn into a 0, right? That is the solution of a polynomial. And that can be obtained either if first term is 0 or the second term is 0. One of those has to be equal to 0, correct? If I simply take the first one, I say x plus 1 equals 0. That implies x is equal to negative 1. Or I could say 5x plus 1 is equal to 0. That will imply x is equal to negative 1 over 5. So there you go. Now you have your two possible zeros of this polynomial from where you started, right? So I would say alpha is equal to negative 1 and beta is equal to negative 1 over 5. If you would like to test our theory that is the sum of these zeros is equal to these relations that we have defined here, you definitely should test it out, and that would be your little homework assignment, that do these relations really work based on what you find using this method that we have. So with that, what exactly is the summary from this tutorial? The summary is that to find the zeros of a polynomial, in the case of a quadratic equation, you are always comparing your given scenario, something like this, to one of these three forms and try to find your zeros based on what you have been given. Either you equate to this one or you equate to this one. Or if you are given only the zeros and you have to convert it back to a polynomial, then you could follow one of these three methods. All right. With that, we will take a pause here, and in our next tutorial, we will talk about how to apply the same fundamentals for a cubic polynomial.